everyone. Good morning. Are you ready? Do you have any question for me before we start? No? Okay, so we are going to continue chapter 3 today. And I'm going to start with this example to review rule 68, 95, 99.7 to find the proportion or probability using normal distribution. So the method we learned last time. Please write this down and try your best to solve A because you should know how to solve it. Okay? I will give you 5 to 10 minutes to figure this out. And then we will continue, and today I'm going to teach the second method using to find proportion or probability in normal distribution, using normal distribution, okay? So the first one, it says suppose, as is roughly true, Americans consume an average of 1.66 cups of coffee daily. Assume American coffee consumption is normally distributed with a standard deviation of 0.21 cups. And then it says, using 68, 95, 99.7 rule, how much coffee does the top 2.5% of Americans drink daily? you know how to solve this, or you forgot? Okay, so let me solve this. So last time we talked about this rule. I said there are partitions here on the normal distribution curve from mu minus 1 sigma to mu plus 1 sigma. Actually, this is not that symmetrical. It should be more symmetrical. We have 68% of our observations, correct? Then I said from mu minus 2 sigma to mu plus 2 sigma, we have what percent? 95%, correct? So from here, mu minus 2 sigma to mu plus 2 sigma, we have 95% of observations. Okay, so now this was just kind of review, and then from mu minus 3 sigma to mu plus 3 sigma, what percent? 0.7%. It says, as is roughly true, Americans consume an average of 1.66 cups of coffee, and a standard deviation for this distribution is 0.21. So we have a normal distribution with 1.66 mu and 0.21 standard deviation sigma, correct? Okay, it says top 2.5%. Now I showed you here 95%, middle 95%, correct? We know all the area is 100%, correct? So 100 minus 95% is 5%, correct? We know this area plus this area is 5%. Is that correct? Yes. So, and I explained, when we are talking about top, means this side of normal distribution, right side, correct? So, this one plus this one is 5%. Each of them are 2.5, correct? 5 divided by 2%. This one, 5 divided by 2%, which is 2.5%. This is the bottom 2.5%. This is the top part. Okay, so the area we are thinking is this one, correct? Yes. This area is 2.5% of American consumption. So this is the line, and this is the point we need to find. Mu plus 2 sigma, correct? So mu is 1.66 plus 2 times. Exactly. So what is that? What is the answer? 2.08. This is the amount of coffee they are consuming. So on this axis we have cups of coffee. Amount of cups of coffee. Or amount of coffee. Correct? Yes. So now we can explain it like this. Top 2.5% of American consume what? 8 cups of coffee, or what should I say? More, correct? Because all the area started from here up to the end, right? So, and we know if this is a cups of coffee on x-axis, it's increasing, correct? So to this side, we have more than 2.08 cups of coffee, correct? Or more. This is the answer for this question. Do you have any question? Sure. Okay. So this was just a review from last time. I remember also last time I don't know if in your class I showed top 2.5% or I'm not 100% sure, but in one of classes I exactly mentioned 2.5%. Okay, so now this was rule 68, 95, 99.7. But this rule doesn't give us all the probability, exact probability we want. So now, today we are going to talk about the new method, z-table. We are going to use z-table z-value to find any probability we want using normal distribution and z-table. Okay, so this is a distribution which has mean of mu, a standard deviation of sigma, correct? I want to say there is this x as a variable, and in this example, x is cups of coffee, amount of coffee. So I want to say this distribution with this mean and this sigma belongs to each cups of coffee. For each cups of coffee, we will have this kind of distribution. This is tilde. Tilde means x has this distribution. So x now we know in this example was cups of coffee. Now we want to standardize each of these x value, amount of coffee, standardize that, and make a new normal distribution. This is a new, but just the x-axis will change because everything else will stay the same. Shape of normal distribution, everything, portions of, area under normal, everything is same. We are just going to normalize all the values on x-axis and make a new x-axis with a kind of more neatly or organized numbers. This new normal distribution will be a standardized normal distribution. This standardized normal distribution has z on x-axis instead of x, and this z is z value that I was talking about, and this z is a standardized value for each of those x. Then there is a relation. I will show you formula. You can convert each x to z. So now z has a normal distribution. So obviously normal distribution should have mean and standard deviation, correct? But the mean and standard deviation will change to 0 and 1. And this is a fixed amount, fixed number. So this is the mean of z. This is the standard deviation of z. Always 0 and 1. Whenever I talk about the standardized normal distribution, always I'm talking about mu equals 0, sigma equals 1. So now let's organize all these mu and sigma on this x-axis. So instead of mu, we should have 0, correct? So it will become 0. Mu plus sigma is 0 plus 1, which is 1, correct? Mu minus sigma is -1, correct? Because we have 0 minus 1. And then tell me the rest. What is mu plus 2 sigma? 2, correct? And then this one is 3. This one is -2. This one is -3. So we just standardize all the value on x-axis. Nothing will change except the numbers are more kind of organized and clean now. Okay, so what percent of observations are from -1 and 1? Can you tell me?
68.
Still?
68.
68, correct? So the area between mu minus sigma and mu plus sigma is still 68%. What percent of observations are from -2 to +2? 95%, correct? Is that correct? So still the portions are exact same. And we have 99.7% of observation between -3 and 3. So now, the formula to standardize each value or each amount of, cups of coffee is this. Z is equal to X. X is cups of coffee, correct? In this example. I'm just using this example to explain everything to you. Minus mean of X. What was the mean of X here? 1.66, correct? Divide by sigma of X. Okay, so let's go back to this table. Now we know the formula. Mu here was 1.66, correct? And then mu plus sigma was 1.66 plus 0.21, which is 2.87? No? 1.87, right?
Yes.
And then this one we already found was 2.08. So let's find this one. 1.66 minus 0.21. 45. Okay, give me this one. Mu minus 2 sigma. 24. Okay, so now. Where is 1 cups of coffee? It will be here. Am I right? Because this is 1.24 cups of coffee, correct? So, should be around here. Lower?
It's actually lower, yes.
So what is mu minus 3 sigma?
1.033.
Okay, so we are here, huh? This is 1 cup. Approximately, here we have 1 cup of coffee, correct? Okay, keep this in mind. Now I want to find the Z value for X equal 1. What that means? I'm talking about 1 cup of coffee, correct? And I want to standardize that X and find the Z for that. So, if X is equal 1 cup of coffee, what is Z value for this X? So what you do, you use the formula, correct? Replace this for what? 1, correct? And then what you will write down here? 1.66, correct? And the standard deviation will be 0.21, right? So let's do this. Z is equal to 1 cup of coffee minus 1.66 divided by 0.21, right? So this is the standardized value for 1 cup of coffee, correct? Obviously this is a negative number, right? 0.66 divided by 0.21. Negative what?
3.14. Do we say all the numbers or just approximately?
Let's keep 2 digits after that. And then again, I will explain that later.
why we need to keep
Just 2. So negative 3.14, correct? This is z value, right? So I should find this z value on this axis because this is a distribution for a standardized normal z, correct? So where is negative 3.14? Now do you understand what was my aim? Compare that 1 cup of coffee with this one, which is negative 3.114. Do you see that? Both of them are before mu minus 3 sigma. So the location is exact same, correct? So if x was here, now the standardized value of x is exact same location. So as you see, nothing has changed. So if I want to see what % of Americans drink less than 1 cup of coffee, we know this area is less than 1 cup of coffee, correct? All the x-axis here shows less than 1 cup of coffee. The area shows proportion of people drink less than 1 cup of coffee, correct? Is that correct? Do you understand this? So this area also shows me the proportion of people or % of people who drinks less than 1 cup of coffee, correct? So now how we can find this to say these two are exact same and answer our question, like what % of Americans drink less than 1 cup of coffee daily? To answer that question, we should find this area, and then this area will be the portion or % of people who drink less than 1 cup of coffee. Now, do you remember I told you to print this out? Do you have it? If you don't have it, you can come here and get one. Okay, this is mine. Bring this back, okay? After class. Return this back to me, okay? Don't forget. Okay, so now, let's open this table. Table A is table for a standardized normal distribution. We will find z value in this table. We will find proportion of observations in this table. So there is the first page and the second page. So the first page, you will see in the first column, all the numbers are negative, right? The second page, you will see the first column, all the numbers are positive. So these are, the first columns are all the value of z. So the first page, which has a negative value, has all the z on the axis to the left side of 0, correct? The next page has all the z on the x-axis to the right side of 0, right? So now you will understand. Let's look at the first page, because our z in this question is negative 3.14, correct? So how to find this z? The first column shows the first 2 digits of z value. The first 2 digits is negative 3.1, right? So can you find that? So negative 3.1, right? The top row shows the decimal, means the third digit. So if I had decimal like 3.10, I would start with 0.00 on the top row. If I have 3.14, means I should look at 0.04, correct? So now, intersection between negative 3.1 and 0.04, will be the proportion or percentage you are looking for. So, did you find the intersection between these two numbers I told you?
Yes.
So, the percentage that you see or the number you see is 0.08. Correct? 0.0008. This is the probability. If the question asks us, what % of people drink less than 1 cup of coffee, we should convert this number you found to the percentage. How? Multiply to 100. Multiply this number to 100. What you will have? 0.08%. Correct? The area you are seeing is 0.08%. Do you understand what's happening? We are using the z-value to find the proportion or percentage or area under this normal distribution. So now, as I said, please be careful. Sometimes question asks you, what is the probability that American drink less than 1 cup of coffee? If they are asking you what is the probability, you will not convert this number to percentage, right? You will say there is 0.0008 probability that American drink less than 1 cup of coffee. But if I ask you, what % of American drink less than 1 cup of coffee, you will say 0.08% of American drink less than 1 cup of coffee a day. Okay, so obviously this is a small percentage. Obviously the area is so small, correct? So now, answer for this question will be, so part B, it says what % of Americans drink less than 1 cup of coffee daily? We will say 0.08% of American drink less than 1 cup of coffee daily. Do you understand this? Okay. So now, some more details about this table. Okay? So, do you have any question? Yes.
I'm just wondering why in the final answer you have fewer zeros than in the table.
Oh, because we multiply that number to 100 because we wanted to find percentage, correct? That's the reason. So if you multiply 0.0008 to 100, you will lose 2 of those decimal, 2 of those zeros, correct? So that's why. Clear?
Yeah.
Okay, good. So now, look at the picture in this first page, top part. The picture shows what area exactly this table gives us. The area this table gives us is always is on the left side of z value. Always. Either this table or this table. Both of picture shows the area to the left side of z value. Correct? So, the first page has a smaller area. Why? Because z are all negative numbers, right? If we find any z here and want to find the area to the left side, the area is much smaller than a positive z. So imagine if my z was here, area to the left side of z was much bigger, right? So these two tables, first page and second page, always answer this kind of question. What % of observations are less than this number? Always it answers less than or decreased or something related to less than. Always answers this kind of question. So now, if you have enough knowledge, you will understand how to answer the other question. Means, what percent of Americans drink more than 1 cup of coffee daily? How we answer that question?
100 minus.
You want to Google it to see what percent of American what percent of Americans drink more than 1 cup? Tell me, that is correct.
100 minus 0.08%.
Correct. Do you understand why? Because the whole area is 100%, right? So if this area was telling us this percent of Americans drink less than 1 cup of coffee, so all the area on the right side tells us this percent of Americans drink more than 1 cup of coffee daily. Correct? So now you have an idea how to solve, for example, part C. Okay? Do you have any questions so far? So now I want to answer more questions like less than, like all the zero are, Z are negative. I want to have more questions like that to make sure you understood how to, find values on the table. And then we will talk about more than, okay? But you already know how to solve it, correct? Okay, so now, find for me, what percent of Americans drink, what? You tell me, a random number. Drink less than or less than what? What cup of coffee? 2? Okay, so let's do that. We want to answer this question. What percent? Of American drink less than 2 cups of coffee daily. So we should keep the formula for Z, right? We know that Z is equal to X minus mu of X divided by sigma of X. So what is the X in this question? Exact. Oops. So X is 2. We should find the Z value, correct? 2 minus 1.66 divided by 0.21. So 2 minus 34, right? Divided by 0.21. What is that?
1.60. To be rounded off.
Okay, so now, as you saw, this table has just 3 digits for Z, right? So keep 2 digits after decimal. Either you are rounding up or round down. You should round it to get just 2 digits after decimal. So from now on, this is our rule. For Z value, we should have just 3 digits, correct? Because the table shows just 3 digits, right? So what, 1.6 what? 3?
Me too, I'm sorry.
2. Okay. So this is a Z value. And it will fall on the right side of table, right? It will be here almost. So look, I'm always, giving approximate number, approximate area, So it says what? Less than?
2.
So less than will be on the left side, right? It says less than because all the cups of coffee here 1.62 on this side are less than. So I need to find this area proportion or percentage of observation, right? Okay, so what is the probability for, or what is the percent of observations to the left side of 1.62?
94.74%.
So second page, correct? 1.6. First we find 1.6, correct? And then we should find 0.02, and that is 0.9474, right? And when we are talking about the percentage, we multiply this to 100. Then we will have 94.4%. So how we answer the question? We will say
94.94% Americans drink less than 2%.
exactly. So 94.74% of Americans drink less than 2 cups of coffee daily. So now a tricky question. Maybe even you don't have to solve it. But let's see who can answer this question. Who can answer this question without solving it? What percent of American drink less than 1.66 cups of coffee daily?
50%.
50%, okay? So why? Because
1.66
in a middle, right? So you even didn't need to convert it to get 0 and say this is the value or anything like that. You could just say from this line, because this is 1.66, to the right side, to the left side is 50%. Because we know mean or median will divide this distribution to 2 exact parts. 50% on the right side, 50% on the left side, right? So 50% of American. Okay, one more question. You know what? Okay, I think, do you feel comfortable you understood everything here? Sure? All of you? Did you understand how to find the z-value and interpret everything? Okay, so now let's move on to the part C to answer this question. And then we will have enough time to go through the, this one also. So, okay, what percent of American drink? This was less than, and now we are going to solve for more than. You already should know, but I want to just write down everything step by step. So tell me, what percent of Americans drink more than 2 cups of coffee daily?
5.26%.
How?
Subtracted it from
Subtract this number from 100, okay? Okay, so. So x is equal to 2. We found already z value to be 1.62. We said the area on the left side of 1.62 is this much. Means we found all the area there here to be 94.74%. The question asking us what is the percent of Americans drink more than, means from here to the right side, okay? So this is the question mark for us. We should find this question mark, right? So we'll just write down 100% minus 94.74% is equal to 0. What is that?
It's 5.26%.
Or we could say 1 minus 0.9474 equal to 0.526, and this is the probability. This is the percentage. Okay? So I will write down area to the right side of z equal 1.62 is 5.26%. So we'll say 5.26% of American drink more than 2 cups of coffee daily, right? So you have to go through all of this, find the z value, and then find the area to the left side of this z value, and then subtract that from 100%, or if you have a probability, subtract that from 1. And then this will be the answer. Do you have any question? No? Okay, so now other question, more than, let's say more than. More than. So this is so a small portion of Americans drink more than 2 cups of coffee, okay? So I want to increase this to maybe 3 cups of coffee to see what percent of Americans drink more than 3 cups of coffee daily, okay? Let's see what we will have. Okay, so what you should do, x is equal to 3, okay? And you will find the z value. So at first, when we are solving these questions, maybe it's good for you to draw a picture and shade the area you want, and that will help you more. But after you have more practice, you don't need to draw any normal distribution to shade any area. It will be like easy for you to imagine what portion you need. So okay, x is equal 3, z is equal to x minus mu divided by sigma equal to 3 minus 1.66 divided by 0.21 1.34. Am I right? I think I'm right. So 0.21 equals
6.38.
6.38. Wow. So this is z value, correct? So where is that? 3 is here, correct? 6 is all the way maybe on the outside of area. 6.38. And imagine we want the area to the right side of this. Imagine. So now you will understand what I wanted to show you in this table. Can you find 6.38 for the z value? Can you? So first of all, what you are going to find, you are going to find the area to the left side of 6.38, right? Because this table just show you area to the left side. And then as you see, the area to the left side is so big, correct? And you have to, at the end, you have to subtract that from 100%, right? So now, look at this table. First, I will give you all the, information I wanted. And then, you should figure out what is the answer for this question. So, first page of this table, we have all the negative z, correct? The first z starts from negative 3.40. Am I right? And then what is the proportion or percentage for that? So small, isn't that? If you want to convert that to percentage, it will be 0.03%. Am I right? Okay. Then, the next z and the last z, negative z here is negative 0.09, right? What is the percentage? 46.41%, right? So as you see, the percentage for a negative, so small z is so small, right? And then the percentage for the z, when it comes to this side, means here, is much bigger. Why? Because the first z you were looking was around here, negative z, correct? And the percentage to the left side is so small, right? And then when you move to this side and you have negative 0.09, the percentage gets bigger because the area to the left side will get bigger. And you have almost 50% because you are getting close to 0. Do you understand everything on this table? So the z is moving to here. The area was smaller and now area is getting bigger. So now, if I don't have a negative, small, tiny negative z on here, what is the area to the left side of that negative, for example, negative 4.02? What is the area to the left side of this? What is that? Tell me. I know you understood. What is the area to the left side of such a z which is so small and we don't have in a table? Less than 0.03. So what is your another kind of guess? You can say almost? Almost 0, right? Almost 0 is almost 0. Correct? So my point is this. If you don't see any negative small z in this table, area to the left side of this z should be almost 0. Correct? So do you get this now? On this page, when we have a small negative z, the area to the left side of that would be almost 0. Right? So now next page. So, next page we have all the positive z. Means all our z are on this side of 0, right? So starting from 0.00, which is obviously 50% of observations, correct? To the left side of this number, right? And then it will increase because z is going to this side and the area is getting bigger, correct? Up to the last number you see is 0.9998, right? So means if your z is here 3.49, the area to the left side will be 99.98%, correct? Right?
Yes.
So now, tell me, what if I have z equal 5.28? What is the area to the left side of this z?
Almost 0.
Almost 1. Because we said to the left side. So imagine your z value is now 5.28. All the area to the left side is almost 100%, correct? Almost 100%. Almost 100% or almost 1. Okay, so now with all this information, what is the area to the left side of z equals 6.38? Almost 1, correct? Area to the left side of this z is almost 1. But what we want now? So what is the area to the right side then? It's almost 0, right? Do you understand that? So what is the answer? 0% of America, almost 0% of American drinks more than 3 cups of coffee daily. Do you understand this? Are you sure? No? Okay, so again. So I said if our z is, for example, 5.28, 3.49. Okay, these are the value, let's say, we have on x-axis, correct? And then as you see, this distribution is getting a smaller area is smaller, right? Okay, at some point maybe even, we don't have any area here for this number 6.38, 5.28, correct? So if we look at the table, area, the last area we have, positive z, we have 3.49. For 3.49, the area to the left side of this number is 99.98, correct? Which means if we move to here, we are almost covering 100% of area, right? So area to the left side of these numbers are almost 100%, correct? And if we want to relate this to the example, we will say almost 100% of Americans drink less than this much cup of coffee, which was 3 cup of coffee, correct? Cups of coffee. 100% of Americans drink less than 3 cups of coffee daily. And then so what percent of American drinks more than 3 cups of coffee daily? So it will be 100 minus 100, which is 0, correct? So is that clear now?
Yes.
Okay, good. So now I think we are done. So let me write down complete answer for this one, and then whoever is done can write down this question, okay? and answer the first part, second part, the third part. All of them, okay? All the three, because you should be able to solve this. So what I wrote down, I said area to the left side of Z equals 6.38 is almost 100%, which means almost 100% of Americans drink less than 3 cups of coffee daily. If we want area to the right side of Z equals 6.38, we should subtract 100, almost 100 from 100%, which is almost 0%. So answer will be almost 0% of Americans drink more than 3 cups of coffee daily. Okay? Did you find? Do you know how to find? How many of you are confident that understood everything? 99. That's a good answer. In statistics, we are never sure, and we always, keep some doubt.
Yeah, 14.69%.
Okay, so let me see. Let's solve it together, okay? So, it says, suppose the pH of rain at one location varies among rainy days according to normal distribution with a mean of 5.43. So, again, I'm going to write down in a kind of professional way. So, X is, now you know what is X? So, it says pH of rainy days, correct? So this will be our X, so level of pH, and then the mean for this is 5.43, standard deviation is 0.54, right? This is mu, this is sigma. Okay, so this is a normal distribution. 5.43 is in the middle, correct? Mu minus 3 sigma, mu minus 2 sigma, mu minus 1 sigma, mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, correct? 16% it says. Using 68, 95, 99.7 rule, what is the pH level of rainfall in the upper 16%, means that this side, correct? Top 16%, right?
Yes.
So now, let's see. This will be symmetric to the other side, correct? There is one 16% here, another 16% on that side. So we have two of 16%. Add them together, you will have total of 32%, right? Subtract 32% from 100. What you will have?
68.
So that is the portion you need. 68%, correct? So if I have, so 68% of observations are between mu minus sigma and mu plus sigma, right? So mu minus sigma to mu plus sigma, this is 68%, correct? And this one plus this one together is 32%, right? So this one alone will be 32 divided by 2%, which is 16%. So which one we want?
The upper 16.
This one. So the value we should calculate is this one and more, right? So we should see what is mu plus sigma. 5.43 plus, which is 5.97, and then pH of rain, correct? Or more. So this is the area we want. So we say upper 16% of rainy days will have 5.97 level of pH or more, right? Because we are going to the right side. It's increasing the level of pH. Are we correct? No. So is this clear? Okay. So the next question says, okay, so now one thing I should mention here. If in a question I ask you to use this rule, you definitely should use this rule. If in next part I'm not asking you to use 68, 95, 99.7 rule, means you have to use Z table, correct? Okay. So now the next part says, what percent of rainy days have rainfall with pH below 4.5, which is less than, correct? So we start with x equals 4.5, right? We should find the z value for this x, which is x minus mu divided by sigma, 4.5 minus 5.43, right? So what is the z value? 1.06. Is this correct, everyone? Did you find the same thing? I'm not going to move. I did that mistake before. I need at least 2 people to give me the same answer so I can approve.
Sorry, what?
70?
Negative 1.72. I was looking at the wrong thing.
Negative 1.72. Okay. Negative 1.72 is the z value, right? So let me draw a normal distribution to show you what is the area in approximately. So this is a standardized normal distribution and 0 is in the middle, right? So negative 1.7 is somewhere around here, approximately, right? And it says less than, so I'm going to shade this area and say I need this area. Do you understand this? Okay. Negative 1.72. So, probability to the left side of z equal negative 1.72 from table A is 0.0427. Is that correct?
Yes.
So if you multiply this by 100, you will have 4.27%. So this one is 4.27%. So what should I write down? 4.27% of rainy days. Tell me.
We'll have a rainfall with a pH below 4.
Exactly. We'll have rainfall with pH less than 4.5. That's it. Correct? Good. Do you have any questions so far?
In the exam, do we have to do this? I was waiting for it.
So in the exam, as long as you find the correct z value, as long as you find the correct area, everything is good. So you don't have to spend too much time explaining everything to me, okay? You don't have to have the picture. This is just for the first 3-4 questions we are solving. After that, we are not going to have pictures. So this is just for you to understand everything better, okay? So you don't have to write down those ones. Any other question? Okay, so the next part saying, what % of rainy days have rainfall with pH above or more than 6? So we start with x equal 6, z is equal to 6 minus 5.43 divided by 54 equal to 0.06. So I'm going to draw a picture. 0 is here. We have a positive z, 1.606, right? And then this is the imaginary line. What area we need? Right side, correct? So we need this area. Correct? Now, from table, find the area to the left side, because we always just can find area to the left side of z, correct? Left side of z equal 1.06. 0.8554, which is 0.8554, or what percent? 85.54%, correct? So here also I could write down 85.54%. So the area to the right side is 100% minus
85.54,
which is
14.46.
So the question mark is 14.46%, correct? So let me write this down, then we will be done. 14.46% of rainy days will have rainfall, help me,
With pH about 6.0.
with pH more than or above 6.0. Do you have any question? So how was this lecture? This should be the most difficult part of chapter 3. So how do you feel? Do you understand everything? Please review everything, please, because if you don't, you will forget everything. I promise you. And luckily this time this year we have these lectures. As soon as you forgot something, you can go back and review these lectures. Is that still recording? Imagine. It is not recording. Okay, so start your homework 3, and next time bring your question to me, and then we are going to continue chapter 3. Still, there are 2-3 more parts to each of these questions, okay? Bring back my table. This is university's property. No, that's my property actually. Okay, we'll see you on Wednesday. Take care.